Okay, so now we're going to talk about the schema theory. Three key schemata relevant to motor control and learning are one, the motor program schema, two, the recall schema, and three, the recognition schema. Let's first talk about the motor program schema. The hypothetical motor program is a mental representation of movement activated prior to movement. What is the program? The best way to answer this question is to identify relatively invariant aspects of movement within a class of actions, such as writing. Indicators are that relative timing or phase of movement components is part of the program, and possibly force ratios across component muscle groups that remain relatively constant in a movement type. Next, we're going to talk about recall schema. The recall schema is an abstract three-dimensional cognitive space relating initial conditions and parameters to movement outcomes associated with prior actions. Initial conditions are those that exist prior to the action. Examples of this would be an acoustic environment in a classroom or a sudden loud noise. Parameters modulate or scale the program. Examples of this are movement magnitude or force magnitude. Outcomes are the monitored movements in the given environment. Cognitive effort is assumed to be involved in the development of recall schema by relating initial conditions and parameters to outcome over increasing numbers of repetitions of movements within a class of actions, like tennis strokes or uttering vowels. Next, we're going to talk about recognition schema. The recognition schema is the relation between past movement outcomes and past sensory consequences for given initial conditions. In the figure here, the parameter dimension is replaced with a sensory dimension. This thought space allows for interpolation between sensory consequences and movement outcome for novel initial conditions. The recognition schema is connected to the recall schema by the shared movement outcomes and initial conditions. Schema theory of motor control. Schema theory accounts for both open and closed loop control mechanisms in motor performance. Rapid movements, which are too fast to respond to feedback control, are accounted for by recall schema. And on the other hand, corrections that occur during slow movements are guided through the recognition schema. Schema theory applied to motor learning. For motor learning, the central concept is that motor programs are parameterized for each trial. The parameters, like muscle strength, timing of muscle groups, etc., need to vary from trial to trial for a person to achieve competent performance, at least within a class of actions. One of schema theory's important predictions is that variable practice should enhance generalization of skill to novel conditions as compared to non-variable practice. Another prediction is that information about performance outcomes is critical for motor learning. Schema theory should be in a position to address motor control and learning for both rapid and slow movements. Now we are going to talk about cognitive process in motor learning. Thought process plays a fundamental role in learning. Distinction can be made between declarative versus procedural learning and association with memory. Declarative memories are conscious. They are revealed by asking people to introspect and, in fact, declare or report their knowledge. Procedural memories reflect skills associated with activities. They are revealed by asking people to engage in previously practiced tasks. Conscious awareness and attention in motor learning. So, procedural memory and motor learning do not require conscious awareness of previous learning episodes or, by extension, awareness of information acquired during prior training. Attention during training is critical for both motor performance and learning. Depth of processing. Depth of processing refers to the type of cognitive operations involved in various mental activities. So, declarative learning generally involves associative or semantic processes, which are considered to be deep. Procedural learning, on the other hand, generally depends on shallower sensory or perceptual integrative processes. The use of metaphoric images is very common in voice training. So, for example, you could tell a client Voice is a wave with no beginning and no end when you're training them to have a smooth voice onset. Metaphoric images are really favorited in voice training. They're super positive and everything, but they might actually impede learning. So we have to be really careful when we use them. So here is a chart that discusses the generally accepted cognitive characteristics of declarative and procedural learning and memory. We already talked about awareness, attention, depth of processing. So this chart just has additional information comparing the two. So as you can see, the speed of processing in declarative memory, it's limited capacity and it's slow. And in procedural learning, it's more fast and it has unlimited capacity. Also, you could see the evolutionary origins. Declarative memory is more new and recent. Procedural memory is more old and it's earlier developing. You can also see stability. Declarative learning and memory is more unstable over time, whereas procedural learning and memory is more stable over time. And lastly, intentionality. Declarative learning and memory is mostly intentional, and procedural learning and memory is often incidental. So, next, we're going to talk about the motivation. It's really clear that motivation is critical for learning. Unfortunately, many patients with voice problems are referred for voice therapy by third parties, and they don't really have any interest in voice. This applies particularly to children. Studies have showed us that watching others perform tasks may be useful to motivate learners. Observation appears to invoke active response for learning. And specifically for vocal training, hearing a variety of samples of easy and pleasant voice productions could be really motivational. It's observed that self goal setting can be really useful and even apparently more effective than do your best type of instructions.